All right, let's learn about something conceptual together. We'll stop so no coding in this video, but very important. And this video will act as a precursor to understanding really what ownership is in Rust. All right, but before we get into ownership, I want to make sure that you guys are clear with the differences between what the stack is in programming versus the heap, particularly in Rust. Right, because that's what we're using. So if you're already familiar with the stack and the heap in general and in Rust, feel free to skip over to ownership. If you're not 100% sure, well, let's dig in. All right, so what's a stack and what's a heap? Well, I want you to think of a stack exactly like how it's worded, like something that's stacked, piled on top of each other. So like a stack of things, right? So these four things would be stacked on top of each other. They're organized, and just by looking at it intuitively, this would be much more organized, right? If this is a stack, let's say, let's put this here. Say that's a stack versus a heap, where a heap would just be just a bunch of stuff heaped, There's no, heap, a bunch of stuff. Well, a heap of things, all right? So we've got a stack of things versus a heap. And hopefully right now, just off the bat, looking at a stack versus a heap, you can see that the stack could probably be much more efficient when you stack things together in order to retrieve these items. Whereas a heap could be kind of messy to retrieve, right? And remember, we are talking about memory. So more of a formal definition standard, the stack would be a very fast issuance where memory is allocated, all right? So the stack is where memory is. Think about primitives. When I talk about primitives, like an integer. When we build an integer of I, and I is 32, right? Or I was dyslexic. I is 23. Or we have a Boolean that's true. We put these on the stack one after another, let's say in a method. All right, and you call that method, you do what you got to do, and then when the method's done, the stack, it just cleans up and it's gone. All right, and you have the stack can just clean up and it's done. It's fast, it's efficient, and by default, most memory allocation in Rust will go to the stack unless it's explicitly assigned to the heap. So again, a method like a function call would be local and would be limited in size. Now, the heap, all right, more formally, is slower, right? Because you're like trying to figure out where everything is on the heap. So that's why you would have pointers that you could point to things like structures that, let's say, like structures that you're storing on the heap. All right, so the heap could be a bit slower. You have to explicitly allocate it, right, by the program. But it's effectively unlimited in size and it's globally accessible. So these are two things which, if you're dealing with more complex data, types, could be beneficial to keep something on the heap. So that leads us to the question, well, if the stack is faster and easier to manage, Clarion, why do we even need this messy heap? Well, a big reason is that stack allocation alone means you only have last in, first order. So one at a time. You're coming in, you're going out. You're coming in, you're going out. You got a stack. We call that LIFO. All right. Heap allocation, though, can be arbitrary, which can be beneficial. If you say, no, I want this to happen in this order for whatever reason. But yes, there is a complexity cost. There's a complexity cost. So since generally when you're programming, you're going to use stack allocation, Rust defaults to stack allocation, all right? But it's important to denote the two, especially moving ahead. And hopefully this makes sense. This would be the kind of quickest way to kind of think about clear explanation about stack versus the heap. Whereas we can have a primitive and a stack, and the heap we can put struct, let's say. Even a struct by default will go in the stack. But let's say for whatever reason you want to take some type of object data, you could move it over to the heap. And so one last thing before closing this lesson is that it's important to point out that Rust does not use a garbage collector. So when you have things on the heap, remember they're going to stay on the heap, but you're going to want to clean them up. So these properties are achieved through a type system. And that actually makes Rust quite efficient, but it also makes it harder to learn. and to use properly. There are, though, libraries out there which you would most likely use. All right, so stack versus heap in a Rust nutshell. Hope that makes sense. Take your time with it if it's a little confusing, and whenever you're ready, let's move forward into ownership in Rust. Okay, I'll see you there.